tried to pick out the Thomas Spring stuff. This looks interesting.
Oh, really? Okay.
So I hope everybody is having a good morning so far. We're gonna finish up this morning, with this class because by the time we are done, it'll be pretty close to noontime. And we got another minute. Okay. So I'm gonna show the whiteboard area first, just so that just so that I don't forget to mention these things, okay? Because that's more like a note to self. Okay, so we do have exam 1 coming up, because it should occur at about 1/3 through the semester, and we are about 1/3 through the semester at this point. In fact, next week is probably closer to 1/3, but I want you guys to have 1 week of time to study and ask questions, and that's why I'm putting the exam on the 29th of September. So the other 2 exams will be kind of more closely spaced. The second exam, the final exam, will be more closely spaced. So I will talk about all of these items when we get to it. So right now we are just waiting for everybody to join us in 5 seconds. All right. There we go, 10:30. Let's go ahead and get started. The lecture is getting recorded anyway, so people who are missing the live session can always just watch the video. So I'm gonna get started anyway. All right, so announcement. We are gonna have exam 1 on the 29th of September. So that's gonna be a Tuesday, which is the Tuesday after next Tuesday. We will have a practice exam next Tuesday, not today, because today I got some material to introduce, but we'll do it on next Tuesday. And the scope of exam 1 is everything up to, but excluding relations. So everything that we have been talking about, set theory, quantifiers, functions, Olive null, all of those, will be included in, they're all within the scope of exam 1. Relations are not. It is an open book, open notes, and really for the most part open internet kind of exam. The only thing that I really do not allow would be collaboration. Okay, so collaboration can occur in many forms, but the bottom line is the grade has to reflect the academic performance of the person who is turning it in, and any attempt to show a competency that is not real will be considered cheating, basically. So collaboration is one method of doing that. And it's also going to be time slot based. Each time slot is the same length as the lecture. So basically, depending on which time slot people sign up for, they get exactly that 80 minutes to do the exam. There won't be any extension of time. So basically what happens is I will share a document that has the questions, and you type your answer within the Google document that I share with you. After 80 minutes, another script will run in order to unshare the document. That script will run, whether people are screaming and kicking and saying that I just need a few more minutes, it doesn't matter. The script doesn't care, and it will just run and unshare the document. So my advice is to have a clock, to kind of keep track of time so that you don't get surprised when time is up. I will send a form to let you guys pick, or let me know of your time slot availability. I typically give people a lot of flexibility. So in other words, as long as I'm not teaching on a Tuesday, I will open up, most of the time slots. But I do teach in the evening on Tuesdays. So that means, after 7 p.m., I won't be available. And everybody will have to pick up one time slot on that day. Okay, so I'm not going to do any time slots on a different day. It has to be a time slot on that particular day. But I open up pretty early. Okay, so I will open up, as early as 9 a.m. and I will have time slots available all the way up to 7 p.m. So I think that should be enough time slot to handle most cases. All right. So are there any questions about exam 1? Okay, I got Joshua typing. All right. Yes, so the idea is I will be available, to quote unquote proctor the exam during those time slots, and as a result, I want people to give me as many options as possible. So this way I can try to look for the best overlap, between all the time slots that people have chosen. So instead of having, like many different time slots throughout the day, and I have to stay online, to basically answer questions about the exam all day long, I want to kind of limit it to maybe 3 or 4 time slots. According to, history, which is, summer, and also spring 2020, typically, I can do everything in about 2 to 3 time slots. So that's kind of my hope, is everybody will kind of try to be as flexible as possible and give me a lot of options. So that way I can look for the best overlap and try to get try to use as few time slots as possible throughout the day. But Joshua, that's a good question. Yes, during each time slot, I will be present online. So in case people have questions to clarify what I'm asking, I can answer those questions. All right. So as you probably can imagine, okay, and probably have heard other professors saying the same thing, with online exams, everything being done remotely, unfortunately, dishonest people, also look at this as an opportunity. Now, I'm not saying anyone in this class is dishonest, okay? That is not what I'm saying. But I am saying that there are dishonest people, and that was historically proven because the number of cheating, or the cases, the frequency of cheating has increased in spring compared to all of my previous semesters. So there have been a sharp increase in spring 2020, and those were the verified cases. So I do have some historical data to back up this claim. As a result, none in summer. That's kind of interesting, huh, Joshua? Because I taught a summer session, CISP440 in the summer, and I did not catch anything. Now, it doesn't mean that nobody cheated, okay? It simply means that I did not catch anyone. So despite all the mechanisms that I have deployed, I did not catch any case. Okay, Joshua is typing some more, and I'll wait a little bit. And this is a good time to let you guys know of today's word for road taking. And Joshua's typed, I was in your 310 spring class. I don't know how you could cheat on that exam with the Google Doc automation. Well, some people try anyway, okay? And then Alex typed, why cheat? Everything is open notes already. Yes, so open notes is great for people who understand all the concepts and just cannot remember everything, or is not confident that that person can remember everything and regurgitate everything. And I really don't think regurgitating or just rote learning is not useful in computer science. Okay, when you go out there and then you actually work as a developer or as a computer engineer, a software engineer, or a computer scientist, I mean, for the most part, you have access to knowledge. So it is not the knowledge that I'm testing. I'm testing the ability to problem solve. So some people may not even understand all the concepts. So as a result, they have no idea what I'm even asking, let alone trying to find the solution. And And Aaron is right. I mean, some people think that, you know, an advantage is an advantage until the advantage is a disadvantage. Because down the line, okay, you know, if somebody really does not have the aptitude to succeed in computer science and somehow got out, you know, as a computer science major, that person will just, you know, basically, you know, be very, very unhappy with, you know, the kind of jobs, you know, that person can get in computer science. I mean, it really is not a good fit. It really is a much better option for that person. You know, I'm saying hypothetically a person, you know, cheated in order to get a degree in computer science. It would be much better for that person to really understand his or her strength, okay, using personality tests and many other tools, and then figure out a major and a career where the strength of that person would actually help in that career, and that would be a much happier life, and you know, just in the long run, it's a much better thing to do. So anyway, I do have to give you guys the key of the road taking thing. So let me just gonna type it here. So it is PITA, you know, all uppercase, which stands for pain in the assessment. There we go. Yeah, exactly. It is a pain in the assessment because from my perspective, you know, I have to think of ways to curb people from cheating. But at the same time, I don't want to penalize people who are honest. Okay, so I cannot just, you know, crank up the difficulty level to an insane one, you know, because that's just not fair. Okay, so I have, you know, other ways to do it. I take it on as a challenge myself, okay, to make assessments that are difficult to cheat in, and if people try, you know, I would be able to tell. All right, so everything being said, I do have to emphasize one thing. In the Google document, do not copy and paste, okay? Do not copy and paste from some other source. So I want you guys to edit within the document, okay? That's one of the counter cheating thing, okay? Because Google Doc timestamps everything, and it keeps a log of everything, okay? So now, don't look at this, you know, as a way that, you know, oh, tech is so suspicious, you know, he's using this tool to prove everybody is cheating. No. It's quite the contrary, okay? Okay, let's say there are two people, person A and person B, okay? That's PITA. So person A and person B, for whatever strange, magical reason, okay, they came up with almost exactly the same answer, okay? So instead of just looking at the finished document, okay, I can go into the editing, okay? Now, if the editing, you know, the sequencing, the editing, you know, the time, the interleaving, and everything else, you know, really show that it's not really likely that one person is copying from the other person, then I would just go like, wow, this is very, very coincidental, but, you know, from what I can see in the log, you know, this cannot be intentional. So it can be used in that way as well to prove innocence, okay? So this is why I do not want people to copy and paste. Now, if you just want to copy and paste from within the document, like, you know, this answer of mine is really close to this answer, you know, of the next question or the next part of the question, you just copy and paste within the same document, that is not a problem. I'm talking about copying and pasting the entire answer of a question, the entire thing. That would not be good, okay? Now, for people who say, you know, but I'm not really comfortable with using Google Document, well, now is a good time to get used to Google Document. I mean, it's really just an editor. If you know how to use Microsoft Word or Notepad, you know, it's no more difficult than that. It can handle mathematical notation, but you're not required to have to use mathematical notation. So as long as I understand what you are saying, you know, you can use the word in instead of using that funny looking, you know, E symbol to say, you know, element of, okay? So I give you guys a lot of options. As long as I can understand what you're saying, you know, it's going to be okay. Omar brings up a good point. It does not support LaTeX, but it has its own equation editor, which is LaTeX based. So in other words, if you know LaTeX, you can use the equation editor within Google Doc. And I think there's a way to turn it into like a simple mode where everything is not GUI driven, so you can just type your LaTeX equation in. I'm not 100% sure, so you might want to double check on that, Omar. Okay, but it definitely has its own equation editor, and it's not difficult to use, and you're not required to use that either. As long as I can understand your notation, it's going to be okay. All right. So do we have any additional questions about exam one? We can come back and talk about these things on next Tuesday too. So we don't have to talk about everything about exam one today. Okay, I'm not seeing any questions. All right, so let's go ahead and get started with the topic. So we're going to finish up Aleph Null today, and where we left off from last time was how do we derive the inverse function. Okay, so this is the inverse function. So I use g as the name of the function that maps a two-dimensional coordinate xy into a natural number n. So the inverse function is doing exactly the opposite. Okay, give me a natural number lowercase n, and I will tell you which cell within that spreadsheet is corresponding to this particular natural number. So it's basically unfolding space. Okay, so if function g is folding space, it's folding a two-dimensional space into a single-dimensional space. G inverse is unfolding space. Okay, give me a natural number, which is a single-dimensional kind of thing, and it will give us back a coordinate in a two-dimensional space. So now we're going to work on the rationale. How do we get this done? Okay, so once again, I talked about this on Tuesday already, but I'll talk about it again today. Instead of giving you just the solution, which is all the way down here, okay, so I don't want to give you just the solution because I want to show you how I worked this out. Okay, now does that mean the way I work this out is really the best way? No, it's just one of many ways. Okay, I'm pretty sure there are more than one ways to do it. Does it mean that my way is really the best way? This is the fastest way to do it? Nope. Absolutely not. Okay, I have no idea what other ways there are to do this. I did not investigate, but this is one way to do it. Okay, but I do want to explain the rationale, because hopefully some of you may find this useful. Okay, learning how to solve a problem. Okay, I think that part is really the hardest part to teach in any type of programming or computer science related class. Knowledge is easy to pass on. Okay, I can just give you the theorems, I give you the facts, and so on and so forth. But showing you how to problem solve or teaching how to problem solve is a whole different thing, because it has to do with stuff that is inside my head that is not based on words. Okay, because problem solving is not something that is word based. Okay, it's really a process that is totally internal to my mind, and so I'm trying to show that at this point, and hopefully some of you may find this useful. I would not be surprised that half the class is now falling asleep and go like, wake me up when he's at the end of this module. I do understand that. Okay, so let's go ahead and get started. So the first thing that we can make use of is g of w0 has this particular form. I use this word w instead of x because I used w before already. W is basically x plus y. Okay. On the other hand, if you're looking at the row, row 0, okay, because y equals to 0, so this particular element has to be coming from row 0. So anything on row 0 will follow this particular form. And in this case, we are looking at w as x plus y. So we're trying to solve this equation. Okay, we're trying to solve what does g inverse look like. Okay, somebody is giving me, I need to figure out what is x and y. But instead of looking at two things, two variables that I need to solve, I'm now saying, well, we know everything on that diagonal line where this xy belongs to. They all have, when we add the x and the y, they all add up to be the same. So I just call that w. So now I have one single unknown. Okay, because I found this single unknown, it is derived from the two unknowns that I know of. It just so happens that in this case, there's a particular rule that x plus y has to equal to w for everything on the particular diagonal line. So let me see if I still have, I think I rebooted the computer, so I just have to start it again. So I'm just going to bring up that picture again. Let's see. We'll discard everything here. Yes. And okay. All right. So recent document. Oh, it was a Google Doc. Right. I forgot about that too. Okay, it was a Google Doc. So let me find it from the Google Drive. I keep forgetting that sometimes I use Google Sheet and sometimes I use LibreOffice. It all depends on what I'm trying to do. Sometimes LibreOffice is just a whole lot faster, and other times Google Sheet gives me a lot more flexibility. So it's good in that way. All right, so I think I call it space fold or fold. Yeah, I think it's space folding. There we go. All right, cool. All right, so so I'm given a natural number. So, but I know, so let's just say that this is the cell, okay, corresponding to the natural number 143. But I know that everything on this diagonal line, okay, including this guy, this guy, this guy, and then on the other side we have this guy, this guy, this guy, and so on. Now, so I know everything along this diagonal line. If you add the x and the y coordinate, it's going to be 16. Okay, so I do not know. Okay, if I'm just given for 143, I do not know what is x and what is y, but I can define w, which is x plus y. So that makes it a little bit easy to solve because now I just have one single unknown instead of two different unknowns. Okay, and more than that, okay, I can now say let's go to row 0. Okay, because if I follow this diagonal line to row 0, okay, so it has to go just a little bit more. Oh, I don't have enough cells to do that. Okay, we can always extend it. Okay, it's not a problem. Okay, we have this, we have this. Oh, we barely have it. Okay, perfect. So we have 16, 0, okay, which is the base of the diagonal line. So the first thing that I need to do is to figure out which diagonal line is this pixel belonging to. Okay, because if I know what is w, then I naturally will know which diagonal line. And w is nice because if I use w0, that will give me the natural number corresponding to the base of that particular diagonal line. So let me move this close to the module, so this way everything related are together. Okay, so we know that the g value, or when we apply the natural number corresponding to that base of the diagonal line where xy belongs to, is going to have this equation, w times w plus 1, the whole thing divided by 2, with no plus y, okay, because y equals to 0 for the base of a diagonal line. Okay, and we know this is going to be less than or equal to n because we know xy, okay, which is the pixel that we are talking about, is along that diagonal line. And the natural number of every pixel along a diagonal line, all of those are greater than or equal to the base of the diagonal line itself. So let me illustrate what I mean by that. So this is the base of the diagonal line, okay, the diagonal line where x plus y equals to 16. So if you look at the natural number of every single pixel along this diagonal line, they're all greater than or equal to 136. Now itself is equal to, so that's why it's greater than or equal to. This is the next one, is 137. This is the next one, 138, 139, 140, 141, and so on. So all of these have natural value. The natural number are greater than or equal to the natural number of the element that is at the base of the diagonal line. Okay, so I made that observation over here. So the first thing I do is to say, okay, now we can establish this inequality. Okay, so we're basically just saying n is given. I know what n is. W is not given. W is something that I'm trying to figure out. Okay, so you look at this inequality and go like, well, how far can you push this? Well, let's go ahead and find out. So we just use algebra, okay, right here on this side. And we say w times w plus 1, the whole thing divided by 2, is less than or equal to n, because that's how we set it up. Okay, this is based on how we define W. And then on the next row, we basically just we distributed the W times W plus 1. So on one side we have W squared, and then on the other side we have just W itself, and they're both divided by 2. So I break it up into 2 different terms. Okay. And then from here to here, I just move things around a little bit. Instead of division by 2, I say 0.5 times. So I subtract n from both sides, so that one side is now a 0. And then the other side, instead of using divided by 2, I use 0.5 times. And by multiplying both sides by 2, then the 0.5 w squared becomes just w squared. 0.5 w becomes w, and then negative n becomes negative 2n. 0 is still 0 because 0 times 2 is always just 0. So are we still doing okay so far at this point? I think the trickiest part is what is w, okay? Because that really is one of the main the tricks of solving this whole thing, is not to look at xy as 2 different values that we need to solve. We just go like, well, if we can find which diagonal line first, okay, and that's just w. Okay, so that really is a main step. Now I know this is an inequality, but you can always still solve it, okay, using the quadratic equation. So we have a quadratic, I guess, inequality, but nonetheless, okay, if you look at this as an equality where w squared plus w minus 2n equals to 0, we can solve for w, right? Because you guys have all taken enough algebra classes to understand what is a quadratic equation and how to solve for the roots of a quadratic equation. So I put this over here. This is just textbook quadratic equation thing. I think it's minus b plus or minus in square roots b minus 4ac divided by divided by 2a. Okay. My memory is really bad. When I worked this out, I had to look up the quadratic equation. Once again, it's just knowledge. Okay, I know how to derive it, but over the years, I don't want to rederive it, so I just look up the knowledge. So, so we can solve for w, but this w is not going to be a very nice w, is it? Because this w is going to be an irrational number for the most part. Okay, unless you have some really unless everything kind of works out in a nice way, w is going to be a irrational number. So if w is an irrational number, it kind of doesn't make sense, okay? Because we know that w should be a natural number. So now the question is, how do we turn an irrational number into a natural number? So what we know is, in order to solve this equation, first of all, okay, the first thing is there are 2 roots. When we solve the quadratic equation, we want to ditch one of them. Okay, so we can see that we have -1 plus or minus this square root thing divided by 2. So that means the negative root, we should ditch it right away, because we know that w should not be a negative number. Is that okay? Does everybody understand why w should not be a negative number? Because okay, very good. Because w is x plus y, and both x and y come from natural numbers. So the sum of x and y cannot be negative. And that's why we can just focus on the non-negative root for w. But that is going to be a irrational number. So now we have to say, okay, if it's an irrational number that solves this equation so that w squared plus w minus 2n is exactly 0, then what should we do to that irrational number to actually get to the w that we want, which is a natural number? So we take this is called the floor symbol. We take the floor of that. Why do we take the floor of that? Because we want this entire thing to be less than or equal to 0, not equal to 0. So if w is slightly smaller than the irrational number, then it will just be less than, right? Because because we're looking at the positive root, so w squared for sure is going to be a positive number, so that one is not an issue. But plus w means if w is a positive number, when we take the floor of a positive irrational number, it will just either be the same if that irrational number turns out to be a irrational number, or it will turn into an integer that is just a little bit smaller compared to the irrational number, which turns this entire side just a little bit smaller than 0, which is still okay, because the inequality says, w squared plus w minus 2n just has to be less than or equal to 0. Okay, so if it turns out to be less than 0, it's not a problem. So that's why we focus on the positive root of w of this quadratic equation, and we want to take a floor of that too. Because basically, when you look at, because this is a positive root to begin with, so taking the floor is basically truncating and getting rid of everything that is not after the decimal point. So now we can solve w. So w is done. So once we solve for w, what else do we do? So now we look into n. Okay, n is given to us. X and y are unknown. We're trying to solve for x and y. But if we just expand g of xy, we end up with this expression here. This is from above several sections before. But when you look at this particular thing, not taking into consideration the plus y, x plus y, hey, that's how we define w. X plus y plus 1, that's just w plus 1. So that's why we can just kind of revert the whole thing back to, oh, okay, we are just looking at w times w plus 1, the whole thing divided by 2. And because this is now the actual pixel that we're talking about, we also have to add y to this term over here to get to the n that is given to us. So using just algebra, we can now say, okay, let's kind of subtract this thing from n on one side, then we are left with y on the other side. So I kind of flipped the sides over here, but if you are familiar with your algebra, you know exactly how to derive from here to here. So now we can solve for y. Okay, so out of x and y, we know what is x plus y, and we also know what y is. So to get to x, it's pretty easy, because once w is known and y is known, then x is really just w minus y, and now we have the whole thing resolved. So the rest are really just kind of notationally, we look at w as a function instead of as a single variable. But other than that, the trick of solving x and y given n is here. Do we have any questions about the entire line of reasoning? It's pretty difficult for me to ask any questions about the derivation, but I would say, understanding how it is derived may be helpful, for the exams. But I think in the end, it's not about the exam. I think in the end, it is about, do you follow my line of reasoning? So are there any questions? Okay, somebody just direct message me, and let me see what that is. Oh, okay. So there is a question about people who might need extra time. So if you have a DSPS paperwork saying that you are allowed to use extra time, let me know. The script picks up the begin and the end time from a spreadsheet. So for the most part, the begin and the end time are calculated, but I can override, the end time for people who have a notification or have a notation from the DSPS office. So that can be taken care of. But people who need extra time, who has DSPS approval for more time, need to contact me ahead of time so that I can manually edit certain entries in the spreadsheet. All right, so getting back to our current topic, do we have any questions? No questions. All right. So the rest of this module has to do with just notations. So I don't want to look at w as a variable, because it really is a function of n. So I define wn, as a function, which is basically really just the positive root, and take the floor of that. Okay. So I just changed that notation, and I worked out a few algebra thing. Okay, so basically in the end, G inverse of n is a 2 tuple, because it has got the x and the y components to it. This is the x component. So the x component is w of n times, in parentheses, w of n plus 3. Now that's not a typo. That really is plus 3. The whole thing divided by 2 minus n. And then the y component is n minus, and this is the one that we are familiar with, which is w of n times w of n plus 1, the whole thing divided by 2. All right. So that's the conclusion. Okay, after all of these math stuff here, this is the conclusion. Okay, G inverse of a natural number is this. Okay, so I can just end this module as it is now and just go like, woohoo, we are done with the derivation. Okay, everything seems to make sense. Okay, Tech probably knows what he's doing. No, well, Tech may know what he's doing, but that is no reason to trust him. Okay, so now we want to say, well, but how can we know that this works? Okay, is there a visual way to show that this works? Well, the answer is actually it's pretty easy to do. Okay, so with Google Sheet, there are a few kind of really neat ways to do this. I haven't done it before. Okay, this is the first semester where I actually did this. So let's go ahead and look at that. Okay, so now we go here. Okay, this is the one that we are familiar with. So the first thing I want to do is to define w as a function, because I don't want to type in that whole thing over and over again. So with Google Sheet, one thing you can do is to go to Tools, go to Script Editor, and that will give you the ability to define JavaScript functions. So JavaScript functions, in this particular setting, are accessible within the spreadsheet itself. So you can custom define functions where it is useful to you. So we'll define w, and the parameter is called n. So now we can just kind of more or less copy the equation that we have. All right, so I'm really bad at remembering equations, and we have to take the floor, and so now I have to look up how to do this in JavaScript. I think it's just a math.floor or something. Yep, math.floor. There we go. All right, so we'll say return. Okay, return a value, which is math.floor of something. Okay, now go back to here. Now this is what I'm talking about, knowledge-wise. Even though I derived every single line of this derivation, if you were to ask me, so what does it look like? What is w of n? I cannot remember it. Okay, I can talk about it like 2 minutes ago, and then I will totally forget about it. So it is 8 times n plus 1 inside the square root. Okay, so we have math square root. What was it again? 8 times n, the whole thing divided by 2, I think. Okay, let me just double check. Plus, okay, 8 times n plus 1. Okay, see, my memory is really bad. All right, so we got the square root, and then what do? We subtract 1 from the square root. Okay, so we take the square root, put it in parentheses, subtract 1 from it, and then divide the whole thing by 2, I think. Yep. All right. Okay, so we then have a close paren here. I think that's it. Okay, that's w. Okay, so the important thing is, at this point, this is still being edited, so it's not saved yet. Okay, so we type Control S on the keyboard. We give the project a particular name. We'll call it, space folding. Okay, it can use the same name as the spreadsheet itself, even though it is technically it is a Google script project that is kind of by itself, an entity, but it is attached to the spreadsheet. So that when the spreadsheet wants to refer to this particular function, it doesn't have to identify that it is inside the project called space folding. All right, so from here, now we get to have some fun. So the fun that we're gonna have is we're gonna define x and y too. Okay, so we go back to here, and now we define x and y. So we say function x of n and then we define function y of n. Okay, and then we go back to the notes here, and basically just enter this stuff here. Okay, one is wn times wn plus 3, the whole thing divided by 2. Okay, so I know some of you are saying we can probably make this more efficient if we just remember w of n just once. Yeah, but we cannot do that between the functions x and y, so we're gonna have to do it. I suppose we can return it as a 2 tuple itself, but that makes it kind of difficult to extract the individual component for display purposes. I suppose we can do that too. Choices. Okay, that's one of the things that INTPs do, is they just come up with a lot of choices in no time, and then they confuse themselves. Yeah. All right, so let's go ahead and do it this way. Okay, so I'm gonna have x, y, and, which will figure out both x and y and return the whole thing as a string. Okay, because the whole point is I just want to be able to display it in the spreadsheet. Okay, I'm not really that concerned of getting the actual value of x and the actual of y. I just want to be able to display x and y. So we'll just go ahead and define here. We'll define tmp as a temporary variable as w of n. Okay, so we now know what x is. Okay, x is tmp times tmp plus 3, the whole thing divided by 2 minus n, and then y is n minus tmp times tmp plus 1, the whole thing divided by 2. I think that is correct. Yes. Okay, excellent. All right, so now that we have x and y as integers, now we can go ahead and come up with the string that I'm going to return. And this is one of the things that I really like about JavaScript, is when you use backticks to specify a string, then it is kind of like it's kind of like a combination of printf in C and the formatting that you can do in using cout. Okay, so I'll show you what I mean by that. So anything, I can type a whole bunch of stuff like the parentheses and the comma to separate the items, and these will be these are literal, okay, in the string itself. So the string literally is starting with an open parenthesis, closing with a parenthesis, and at this point with a comma in between. But if I use dollar, okay, dollar, there we go. So now I can insert values that are computed in JavaScript, and I can use just about anything within the braces. So in this case, it's really kind of simple, because I really just have x over here, and I really just have y over here. Okay, so that means all of these local variables, x and y, are not really needed. I could have just put in the equation into here, but this makes it more clear, which one is x and which one is y. So it's easier to debug the program this way. All right, so before I go any further, I'm going to type Control-S to save the file. And instead of just plugging this in right away into my spreadsheet, I think it's a good idea to test it first. Okay, so I'm just gonna I will have another function here called test xy. Okay, because all it does is to test x and y, and it does not have any parameter. In other words, I have to use constants for n inside the function itself, and the reason is going to be explained in just a little bit. Okay, so just to be very clear, okay, and also to have a single place to change when I want to test it with a different value, we'll say let n equals to 143. I think that was the value that we were talking about when I explained g inverse. And then we have the actual return value. Okay, so we'll say let result here is xy of n, and that should give us the same x and y that we were talking about just a little bit earlier. And we'll just say that okay, it will also return the result, okay, which we don't really care about that line. Okay, we just want to test it up to this line here to know what result is. So Control-S, save it, the whole thing again. We put a breakpoint. Okay, so now this is the really kind of important part, is I want to be able to test this code first. So we go to run, we go to debug function, and then we go to test xy. So this is basically triggering the execution of the function test xy from outside of the functions, okay? And because it doesn't take any parameters, so it's perfectly okay. Okay. And we're hitting the breakpoint. So once we hit the breakpoint, we can look into the local variables to look at result. And result sets 97. Okay. So now we go back to the spreadsheet itself and look up 143, and it is 97 indeed. Okay. So I have a basic mechanism now to verify that I got the values correctly. Okay. So the original intention of xy as a function is so that I can do it over here. In other words, I can extend each one of these cells to also show what the inverse of the natural number is. Okay, but that's going to take a little bit of time because I'm basically reversing this natural number back into the xy coordinate and display as a part of the string over here. But I'm fairly sure that most of you are already convinced that that function works, because if you just pick another value here, right? So we'll pick 487. Okay, so 487 should be mapping to the coordinate of 822. So we'll just go ahead and change my test function here. Instead of 143, we have 487, I think. Yep, 487. And then we just test run the whole thing again. Go to run, go to debug. Okay, if you just run, it won't stop at the breakpoint. So you have to use debug function. And then we go to test xy. And we are now at the breakpoint, which means result should be computed. And it's right here. It's 822. So this is how I can kind of use a spreadsheet to help myself verify that the equations does work. Do we have any questions at this point, other than is the exam going to include JavaScript and Google Sheet? Of course it does include that, because if I talk about it in class, it's going to be included in the scope. I'm just kidding. Now, I'm only half kidding. Okay, I should say I'm only half kidding. You can use the spreadsheets that I have developed. Okay, so if you make a copy of this spreadsheet, you can use it. Okay, when you are working on the exam. So any resources that is available to you prior to the day of the exam, okay, not prior to your time slot, okay, it has to be prior to the day of the exam, you can use. So that includes all the YouTube videos. Okay, if someone says, I'm not really quite sure, what about blah blah blah, okay, a particular topic, but I have been keeping a really good catalog of text topics, so can I go back to the recording of that particular lecture and watch just that segment, so that I can answer the question? The answer is yes, perfectly okay. Okay, there's no problem with doing that. And some of you probably already know, how to track down past recordings of all of my classes, since I think 2012 or so. Okay, and somebody may be thinking, hey, maybe Tech is reusing some of his questions from the past. So maybe if I go back and watch some of those videos, I can just copy and paste the answer. That is perfectly okay as well, because I can promise you that I do not intentionally reuse the questions. Now, does it mean that I may not remember what questions I have asked before, in the prior 8 years, and just accidentally reuse the same question? That's totally a possibility. Okay, I don't know what is the probability, but it is a possibility. Okay, so even that is okay. Okay, people can actually go back in my published videos and try to search and glean for the answer. Okay, not a problem. But contacting another person during the test, or asking another person, hey, you took the test this morning, can you give me an idea of what the questions are? That is not okay. Okay, so there is a very clear line of what is and what is not okay when it comes to the exam. Oh, Joshua just commented, that's going to be tough to do in 1 hour and a half. Well, I would say it is, but I'm not going to stop people from doing something that I think may not be very fruitful. I'm just saying that it's okay with me if people want to do it. Okay, I'm not saying anything about is it a wise thing to do. Okay, all right. So do we have any questions right now? Because we have just come to an explosive conclusion of this particular module, that we can fold space and then we can unfold space. Okay, nobody has any questions. No one is jumping up and down and go like, yes, this is so cool. Okay, all right, I can understand it. All right. All right, so if there are no questions about this module or how things are derived, now, even though the derivation itself is not going to be quizzed, does everybody understand what is the function g, what it does, and what is g inverse, what it does, and how it relates to g? That part is going to be important in the exam. So do we have any questions about that? Okay, I'm not seeing any questions. All right, so that means we are ready to move on, and we can now start on relations as a topic. So remember, relations is not going to be in the exam. So what we are about to talk about starting now is not in exam 1. All right, so I'm just scrolling through. Olive No is technically done at this point, and now we are starting on relations. All right, so relations is kind of interesting, okay, because it might remind you of something that we have already talked about in the past, and yet it is not really the same thing. Okay, Joshua is typing something. I'm gonna give him a little bit of time, and I'm just gonna scroll to the right point to get started here. All right. All right, so Joshua types, sorry, one more question about the exam. Will I post the review from exam 1 today? I will dig through my stuff and see how that was done in spring, because I cannot remember whether exam 1 was prior to the COVID-19 lockdown. I think exam 1 was before the lockdown, so the format is going to be different for your test. But it's going to be the same kind of question. Okay, Joshua is typing a little bit more. Okay, it was before. Okay. All right, cool. So I'll go ahead and dig up something, and what I'll do is I'm going to post it in the shared folder, and then I'll send it an announcement once it's done. And if you don't see it sometime today, you'll just kind of give me a nudge, because I might have forgotten to do it. All right, thank you. All right, so let's move on to relations. So a relation is, so when we use the term relation, it is basically technically saying whether two elements of a particular set are related or not. Okay, this is it. Okay, whether two elements of a set are related or not. Now these two, so this is not really a good way to say it, because those two elements, so to speak, can be the same element. In other words, we can ask, is an element relating to itself? Okay. So technically speaking, mathematically speaking, if you give me a set of X, I can now say, okay, let's look at a relation R defined over X. Okay, that's basically just how we write those terms. So the first thing we know is R is a subset of the Cartesian product of X and X itself. So this might remind you of functions, right? Because a function has a domain and a codomain, and a function is a subset of the Cartesian product between the domain and the codomain. So it might remind you of that. But there are certain things that are very different between the two. First of all, in the case of a function, the domain and the codomain do not need to be the same. Okay, so you can say the domain is, well, I mean, we have just gone through an example, right? Because the domain is two-dimensional space, and then the codomain is just the natural numbers. So a function doesn't need the domain and the codomain to be the same. But when we are talking about relations, then they have to be the same. So a relation has to be a subset of a Cartesian product where the two sides of the operator, the Cartesian product operator, have to be exactly the same set. Okay, so that's the first thing that I want to clarify is this is not the same as a function. All right, so that automatically means every element in R, which is a relation, is a two-tuple. It's a two-tuple because of the Cartesian product. Okay, the result of a Cartesian product is a set where everything in the set are two tuples, where the first element is coming from the first set, whatever is to the left-hand side of the Cartesian product operator, and then the second element is coming from the set of the right-hand side of the Cartesian product operator. Okay, so that's the first thing we notice. The other thing, from the notation perspective, we can also say, instead of saying x relates to y via r, we say x r y. Okay, so x relates to y by r. Okay, so this is the infix notation of a relation. Note that x r y is not an assertion, it is really a question, more like. Okay, it's basically asking, does x relate to y? So the answer can be true or false. Okay, all right, so let's go ahead and I'll write a few examples, okay, not in section 3 but just in 2, okay, in section 2. So here are some of the examples that I am going to use. So let me switch to the quote-unquote whiteboard area first, and then I am going to type something here to illustrate that. Okay, examples of relations. Okay, so the first thing about defining a relation is you first have to define what is the set where the relation is defined over. So now we'll go ahead and define X as the set that we are concerned about. And this set doesn't have to be like natural numbers, it can be anything. Okay, so it can be A, B, C. Okay, yeah, I'm just using that because they're easy to type. Okay, so we define X as just the set of A, B, C. So now we can define R. Okay, so R has to be a subset of, okay, subset EQ of X times X, which is the Cartesian product of X and itself. Okay, but that's the only restriction of what R can be. So in this case, there are many possibilities for R, because we are basically asking how many subsets are there of ABC crosses ABC. Now we know ABC crosses ABC has 9 elements in it. Okay, but the question is not about that. The question is saying, knowing the Cartesian product has 9 elements, how many subsets are there corresponding to X Cartesian product with X? Okay, and that's a lot. Okay, because we are basically looking at 2 to the power of 9, which is 512 possible relations that we can define over X. Okay, so we'll say there are 512 possible relations that can be defined over X. 512, once again, is because of 2 to the power of 9, and that 9 is coming from the cardinality of the Cartesian product. So let me go back here and explain why 512. Okay, because it has to do with 2 to the power of the cardinality of X Cartesian product with X. And that should end that. Okay. So let's look at one specific one. Okay. Let's look at some specific possible relations. All right. So one example is, I think most of you probably have this in your mind, is can a relation be empty? The answer is yep, perfectly. Okay, a relation can be empty because what that is saying is nothing in X relates to anything in X. Okay, well, does it make the relation useful? No, not particularly. But can that be used as the definition of a relation? The answer is yes. Okay. In fact, an empty relation has certain built-in properties already. Okay, so that's something that we're going to see later when we start to define properties of a relation. Another way to define R is the entire thing. Okay, can R actually equal to the Cartesian product of X and X itself? Okay, the answer is yes. Okay, so in this case, every element is relating to every. Okay, let me put it this way: every element relates to every element in the set of X, including self. Okay. Let's go ahead and look at another one. Okay, so you can define R as a set, and in this case, it's going to be a subset. Okay, so we can say AB and BC. Okay, so this one is interesting in a way because you can see how AB is in the set, but BA is not. BC is in the set, but CB is not in the set. Okay, so that means the ordering is important because remember AB. Okay, let me point which one we are talking about. This AB here, it is a two-tuple, which means the order is important. So in this case, it simply means A relates to B, which does not automatically makes B relating to A. So relations are not automatically bidirectional. Okay, when I say A relates to B, it doesn't automatically mean B relates to A. Let's look at this particular case. Okay, so if I use R, if I define R as this, okay, what do we know? Okay, so we can now say ARA is false because A does not relate to itself. Okay, otherwise AA would have been an element in this particular set. ARB is true because A does relate to B. And how do we know that? Because AB is a two-tuple in the set. A does relate to B. Okay, so when we are using this notation, 0 means false and 1 means true. Okay, let's reverse this. Okay, let's look at BRA. BRA is false because B does not relate to A. So this is exactly what I was talking about earlier. ARB is true because the two-tuple AB is in the set R, but BRA is false because BA as a two-tuple is absent from R. So that means they're not automatically, it's not bidirectional. So do we have any questions about this whole thing? No questions about the concepts? No questions about the notation? Okay, now I'm going to just kind of add a little bit here. Okay, I will just say because. Okay, and I'll use AA as a two-tuple in R is false. Okay, and on the next one, I will say because AB in R is true. All right, so Alex has a question. A relation is used only for, a relation is used for only a single set, not comparing elements in two different sets. That is correct. And that restriction comes from, R has to be a subset. of the Cartesian product of the set that the relation is defined over. Does that explain it or not, Alex? Okay, all right, cool. All right. So do we have any questions about the examples over here? Okay, no questions. All right, if there are no questions, we're going to go back to the notes and then move on to section 3. So section 3 is an example of what exactly is a relation. Why do we need to know about relations? So one relation that we are all familiar with is the less than operator. Then somebody's going to say, but less than is a comparison operator. It is not a relation, but it is a relation, okay? Because it is a relation, it says whether two things are related by less than, okay? So if I were to define, a relation over all integers called less than, then 1 is less than 2 is true, but that's because 1, 2 as a 2 tuple. I know this looks really strange because I'm looking at the less than symbol as the name of a set. Okay, so that's why I use this notation here, which is 1, 2 as a 2 tuple is in the set called less than is true. Okay, so I know this is kind of a little bit tricky to read because most people look at less than as an operator where there has to be one thing on the right hand side and there's another thing on the left hand side, but I'm looking at less than as a relation defined over integers in this case. So that's why instead of saying 1R2 where R is the name of the relation has a name of less than, okay, or using the less than as a symbol for that particular relation. So I can now just basically use the symbol that we use for less than as if it is the name of a relation. All right, so Joshua is typing something, so we'll go ahead and wait a little bit. All right, so aren't all numbers in less than? Okay, so that is an interesting question. So let me go ahead and see how I can answer this. Okay, let's go back to the whiteboard. Okay, and we'll go ahead and look at that. Okay, so let's go ahead and put it here. Okay, all right. All right, so we're gonna say less than is a relation because it is a subset of integers times integers. Okay, not I. Integers use the Z as the letter. There we go. All right, so the first thing is we are defining less than as a relation, okay, as a set, and this set has to be a subset of the Cartesian product of integers and integers. So when I use this notation, I am talking about integers in the sense of mathematics and not talking about integer type in C and C++, because in C and C++, as a type, integers is not the same as this Z notation here, because there are only so many integer values that you can represent, even if you have 64-bit integers, which has a lot of values that you can represent, but it is still finite. Z in this case is denoting the set of all integers, which is a set that has an infinite number of elements. So I just really kind of want to make it clear on this one first. Okay, so then we're going to look at this and ask a few questions. Okay, so we'll ask, okay, first of all, we look at this from the perspective of a set. Okay, so we'll ask 1, 2 is an element of it's an element of the less than relation is what? Is that true or not? Yep, it should be true based on what we know about less than. Okay, we'll go ahead and ask another question then. What about 2, 1? Okay, we just flip it around and ask, is that in less than as a set? I forgot about the heading here. Okay, this is false. Okay, very good. Okay, and let me see, I think I put $1 too many over there. There we go. All right, so Joshua is asking why or how or what the heck. Okay, the single question mark can be interpreted multiple ways. Because I'm looking at less than as a set, okay, but it is also reflecting, whether integers relate to each other based on what we understand as less than. Okay, so when we look at 1, 2, okay, and we ask, does 1 relate to 2 through less than? That was the question, and the answer is yep. Okay, that is true. But when we ask the second question, which is 2, 1, which is basically translating to, does 2 relate to 1 through less than? The answer is no, because it is the order is important. So this means another way to look at the set, okay, is like this. Okay, you can look at less than as a set. Okay, and if I want to sort of enumerate some of the elements in it, you'll find 0, 1 to be in it. You'll find 1, 2 to be in it. You'll find 200 to be in it. You'll find -4 and -3 to be in it, and so on. Okay. Now, obviously, this is not a very good way to describe it, but that's kind of these are some of the elements that we can find in this particular set. Okay, because remember, we are looking at a relation as a set of 2 tuples. So this is just a sample of what we can find in that particular set. It's not possible to enumerate, okay, to list all of the elements, because there's an infinite number of integers to begin with. So this particular relation has an infinite number of elements in the set itself. Okay, very good. Excellent. All right, so let's go back to the notes. Okay, move on to the next one. Okay, this one is just a random example, which we'll probably just kind of ignore for the time being. Okay, and instead we're going to look into special properties of relations. So the special properties of relations in some way is kind of from the perspective of these are just qualifications of relations. They are somewhat similar to injection, surjection, and bijection being properties of functions. In other words, you give me a relation and I can tell you whether it is reflexive, whether it's symmetric, whether it's transitive, whether it's anti-symmetric, and the other ones. Okay, much like if you give me a function, I can tell you whether it is injective or surjective, or whether it's bijective. Okay, it's kind of the same thing. So these are qualifications that we apply to relations. So as such, okay, it is important to understand how they are defined. Okay, so we'll start with something simple. Okay, we'll start with whether a relation is reflexive. So we'll look at the definition here. A relation R over a set X is reflexive if and only if the following is true. Okay, so we are looking at this here as a statement that can be either be true or false. And all it says is for each e, lowercase e, in X, e is in R. Okay, this is the requirement for a relation to be reflexive. All right, so let's go ahead and take a look at a few examples. Okay, so you guys can use your own browser to stay on the page where you can see the definition of reflexive, and I'll go ahead and work on some examples. All right, so let's go ahead and first of all we have to define X. Okay, what is the relation defined over, and we'll just use ABC. Okay, just to keep things simple. And now we start to define relations, and then you guys can tell me whether that relation is reflexive or not. Okay, so we'll say if R is defined as the empty set, is it reflexive? Does it meet the requirement that for each element in X, that element relates to itself? The answer is, come on. The answer is no. It does not. It does not meet the requirement. Okay, okay. First of all, I'll say it is not reflexive. Then I go back and ask and answer why it is not reflexive. Okay, so when you go back to the definition, okay, when you look at this here, it's basically saying, if I find anything in X, okay, if I find any element in X, I'd better find that element and itself in a two-tuple in R, because if that is not the case, then the relation is not reflexive. Is that okay? Let me do this other thing too, okay? Because I want to relate the for all operation to things that you already understand, which is basically coding. Okay. All right. So let me. I don't know whether I can do it this way. Using a point and then quote. Sort of. Okay. All right. That's fine. All right. So I'll try to do it this way and see whether it works. Oh no, doesn't like that. All right, so let me see if I can type some Java code here. Oh, C code. Okay, so I'm going to use C code here, or C++. Okay, because C++ has bool as a type. No, it doesn't like it either. Okay, fine. Okay, I think the quotes have to start here, and then let me see if I can use C++ syntax. There we go. Okay, so for all is, if I look at for all as a function, then it takes a set, right? So it takes a set of, I'll call that, okay, fine, we'll use the same symbol here, x, okay? It will also take another function, okay, which is the predicate. So the predicate is basically a Boolean function, and this is how we can define a pointer to a function in C and C++. So it is a predicate which I will call P, and P is going to use a particular element. Okay, so we'll say element type, and that's lowercase x. Okay, we'll use a different symbol here. We'll use E over here. That closes that paren, closes that paren. Okay, there we go. So now, how do we define the body of this function? So basically what it is you need to have a loop to go through every single element in X first. But we're going to have a local variable bool, which is our result. So the result is by default, defined, initialized to true. And then what we do here is we have a loop. Okay, there's no easy way to say this in C, because in C and C++, this sort of thing just doesn't exist. Okay, so what we'll do is we'll say for, okay, I'm looking for a different variable here, for W in X, which is a set. Okay, we are going to do the following. So for each W in X, we're going to use, we will execute whatever is in the current curly brace, which is right here. And that is just going to say result is result and, okay, this is ampersand ampersand P of W. Okay, and I'll explain that in just a little bit, and then we'll go ahead and end the subroutine by returning result and a semicolon. Okay, there we go. Does everybody understand this notation? I know this is like pseudo C, because C really does not have a built-in syntax as an iterator to go through a set, but does everybody kind of get the gist of it? This is a loop, okay, and each iteration of the for loop will use one element of X as W. So are we good with this? Yup. Are there any questions about this syntax? Okay, we all good? All right. Okay, cool. So that means, if X has 20 elements, this loop will go through 20 times. Okay, so that is the important part. So the more important part is when you look at how result is updated. Okay, I'm missing one more semicolon. Not that it is important, but it is, just since I spotted it. So the important part here is when result is updated, it is always updated with whatever it had conjunction with the result of applying P on the element that we are looking at for that particular iteration. So P of W can come back as true, it can come back as false, right? But when it does come back as false, it will turn result false. But once result is false, it will always stay false. Even if there are other PW that are true, it won't turn it into true again, because we are always using conjunction to link all of the PWs together. Does that make sense? We good? All right, cool. So now when we look at what we are trying to look at here, which is what makes a relation reflexive, it is basically saying this part here is defined is the P function. Okay, the P function says E of EE has to be in R. But since R is an empty set, that is going to be false for every single element. So that means when we go back to the pseudocode over here, if P is EE is in X, then P of W on this line would have returned false no matter which element you pick from X. So that means result is guaranteed to be false by the time we get to the return statement. Does that make sense? Does that explain why if R is an empty set, it is definitely not going to be reflexive when X is not empty? Because what is happening is I will, in the first iteration, I will look at W equals to A, okay, element A, and then the question is, does A relate to itself? Well, since R is empty, A is not relating to itself, so that means we have a false already just by looking at A. And as if that is not enough, because we are following this loop here, we look at B. B is not in R, so that means we have another false over here, and then CC is also not in R, which means we have another false here. So result basically turns false the first time when we try to say what happens when W equals to A, but for both of the other elements, it will also return false. So is that okay? Does everybody understand why if R is empty, then and X is non-empty, then it is not reflexive. R is not reflexive. So are we good with this one? Cool. All right. So I do want to point out that even though in C it is not doable, it can be done in JavaScript. So I'll go ahead and give you the exact code in JavaScript. Okay, so end this quoted segment, start another one, and this one is JavaScript. I'm using Markdown, and Markdown really has all kinds of really cool features, just such as this. Okay, so in JavaScript, I can now define the function for all. Okay, it's going to take X as the set, and it will take a callback function P. Okay, just like in the C function. But since JavaScript is not a typed programming language, I don't have to say what is X and what is P. All right, so Omar is asking, I'm curious if you can also show why empty set is symmetric and transitive. Okay, so I'll define this first. Okay, I think we may not have time to explain why it is symmetric and transitive, but once I'm done with this, I'll make a point, okay, Omar, so that you probably will get it because you have been thinking about this already. Okay, so let me finish this first. So in JavaScript, if X is indeed a set type, then there's a built-in method called for each. already defined for it. Okay, and I still need to have a local variable, and the keyword let is one way to define a local variable. So I'll define result to be true, just like in the case of the C program. So it has kind of the same logic. So when we use for each, okay, I'm using a shorthand for an anonymous function that we can pass to for each. So the anonymous function is going to use e here, as a parameter, and then this kind of wacky symbol, the equal greater than, is a very shorthand thing for JavaScript to define a function, an anonymous function where e is a parameter, and then the curly braces is really not needed here, but I'm going to include it. So for each element of x, I'm going to say result is result and p of e. Okay, so there's no special thing that we need to do if p is a callback function, which can be anonymous or not anonymous function. I would apply that function p to whatever e is bind to for that particular iteration. And then when this is all done, I just have to say return result. Okay, so this is for each. Okay, the top one, what you see here is kind of pseudo C, C++ code. This one here is actual JavaScript code. Okay, JavaScript is really cool in many ways. So if you have a chance to learn a different programming language, I don't know about Python. Okay, Python may be a really cool language to learn as well, but I can tell you that JavaScript is really cool. Okay, there are a lot of things you can do that it would be a lot lengthier and a lot more complicated to do it in C and C++, even Java, but in JavaScript it's like that. So anyway, so getting back to Omar's question. Okay, so for the rest of you guys, if you want to leave right now, it's fine. Okay, at noontime is my office hour, so I'm gonna stay behind anyway. But to answer Omar's question of why the empty and empty relation is symmetric, it has to do with how we initialize it. Yes, so it has to do how we initialize it. We initialize result to be true. Okay, so now the question is, what about P of E in the case of symmetry? Symmetry is it uses if and only if. Okay, so let me this is a preview for the rest of the class. So if you need to leave now, that's okay, but if you are still with me here, then we go back to the module first. So symmetry uses if and only if here, which basically means if EF is in fact in R, then we better make sure FE is also in R. So now the question is, what if EF is not in R and FE is also not in R? What is that going to do with the if and only if? Aha! The if and only if is still true because it ends up with false on one side and also false on the other side. So the if and only if is true, okay, when both are missing. Now, if R is an empty set, that means no matter what you're trying to find in R, the answer is always false, right? So we always end up with false on one side, and we always end up with false on the other side of the if and only if when R is an empty set. So that means no matter how you choose the if, the E, and the F, which are elements of X, we are guaranteed that the if and only if is true. So that means, going back to the JavaScript code, that means whatever we do with this PW is always going to be true. So we end up with true and true, true and true and true and true, and as a result, by the time we get to the return statement, it's going to return true. Does that explain it, Omar? So I think the trick, of understanding symmetry and many of the other ones has to do with the operator, has to do with the if and only if operator. Because in order for the if and only if operator to be true, we only need to be saying, is the left hand side the same as the right hand side? Okay, if one is false, is the other one also false? If one is true, is the other one also true? So as long as they are the same, on both sides of the if and only if, the if and only if itself as an operator returns true. Okay, excellent. So some of the other ones are even more tricky to understand. I would say symmetric is a good is a good warm up to the other ones. I think anti-symmetric is one of the most confusing ones. Is anti-symmetric. Transitive can be a little bit tricky, but we already understand what is transitive in algebra. Okay, so for most of us, we have a kind of intuitive understanding of transitive already. But anti-symmetric is a really funny one, because anti-symmetric is not symmetric. It is something that is that's by itself. So we'll talk about this next, probably next Thursday, because next Tuesday we're going to talk about the practice exam. But it won't hurt to read ahead of me, because this stuff does take time to absorb and understand. And if you guys have any questions, you can use the text channel to ask questions. And also there's a LaTeX playground. If you want to kind of play with LaTeX, you can definitely go there and just kind of try out, how to enter equations, which is not needed for the class, because I don't need you guys to know how to use LaTeX, but it might be a handy thing to know, now that all your math classes are also online. So if you have got some math classes online and you want to know how to impress your math teacher, so you can enter like your really complicated triple integration, and format everything nicely, that is something that you can potentially do. All right, cool. So what I'll do is I am going to take a 10-minute break, and then I'll come back for my office hour. So I'll be back at approximately 10 past noon. Okay, so I type in here. And you might want to use this time to participate the road taking test. And once again, the word for road taking is PITA, all uppercase, which stands for pain in the assessment. Cool. All right, so I'm gonna turn off the live stream for now, and I'll be back in 10 minutes.